Okay, good day everyone. This is a video recording to cover the post-lab discussion for the two experiments for OrgMedChem lab, which is the synthesis of methyl salicylate and the synthesis of ethanol. Okay, so I'll start first with experiment number 5. Now, the contents of this post-lab discussion is we will start with a brief overview of what happened in the experiment, followed by answering the answers to the chemical tests and the follow-up questions. Now, we start with the review of the procedure. We started with um, or rather we started with by mixing methanol and salicylic acid in a round bottom flask. We also added concentrated sulfuric acid after, followed by the addition of some or few boiling chips. And then we heat the mixture under reflux. In the procedure, it stated there we should heat it for 2 hours. But for the sake of time, we reduced it to less than 1 hour, actually. Okay, now after heating and after cooling the mixture, we were supposed to add 20% sodium carbonate. Now, sodium carbonate, it is a basic substance. Now, the purpose of adding sodium carbonate is to neutralize any sulfuric acid and unreacted salicylic acid. Because theoretically speaking, when we react methanol and salicylic acid, the formed product or the main product would be methyl salicylate. Now, obviously, there would be some reactants that would not react. So the purpose of adding sodium carbonate is um, to increase the purity of our sample or of our product rather. Now we have uh, the illustration here. We have the reactions by which sodium carbonate reacts with your sulfuric acid and your salicylic acid, forming the products sodium sulfate and sodium salicylate. Now, both of which are considered as water soluble. Now, the next thing, how would you be able to remove these water soluble products from our mixture? Diba, after the experiment or after this step, we place the mixture in the separatory funnel along with hexane. Now, hexane is considered as an organic solvent, whereas methyl salicylate is an organic solute. So, like dissolves like, technically, methyl salicylate will be dissolved in the hexane layer. So the purpose of adding hexane would be to allow the methyl salicylate in the previous mixture to go into the hexane solvent or hexane layer. Okay, now after shaking the mixture, what would happen is that if you place the separatory funnel, allow it to stand for some time, there will be obvious separation of the mixture. Yung sa baba, that's the aqueous layer. And then yung sa taas, that would be the hexane layer. Water is denser than your hexane, so it will sink. Now, after draining the aqueous layer, and then after subjecting it to another wash, di ba, we subjected the hexane layer to water bath. Now, purpose of water bath is to evaporate any remaining aqueous layer that could be present in that mixture. We also added magnesium sulfate as a drying agent to to increase the purity of the methyl salicylate that we produced. So this is the chemical reaction involved in our experiment. Salicylic acid plus methanol forming methyl salicylate plus water as a byproduct. Now this type of reaction is what we call or what we consider as an esterification reaction, wherein an ester is formed from reacting a carboxylic acid, which is your salicylic acid, plus an alcohol, which in this case is your methanol, along with water as a byproduct of the reaction. Okay, now we have the identification tests, physical and chemical tests. Physical test, it is used to categorize or characterize rather the physical properties of the compound. And then for your chemical test, they are used to characterize a compound based on the presence of certain functional groups. So physical tests for your synthesized methyl salicylate. By the way, this picture, this illustration uh is the product that I made when I did the experiment before. Okay, so we have the color, light yellow to yellow liquid, called odor, uh, oil of wintergreen, odor. Appearance is liquid. Okay, and then for chemical test, we only have one chemical test, reaction with ferric chloride. Now, you had reaction with ferric chloride before in experiment number 3. Ferric chloride test, it is used to indicate the presence of phenols in your mixture. Now, your methyl salicylate, if you look at its structure, it has a phenolic functional group. So obviously, it would give a positive result with your ferric chloride test, which is the purple or violet coloration due to the formation of your iron salicylate complex. Okay. Then to proceed, we have the follow-up questions. The first one, what is the mechanism of methyl salicylate formation? Again, I mentioned this one. It is due, or the mechanism involved rather is esterification reaction. A carboxylic acid, when reacted with alcohol, forms an ester with water as a byproduct. Number 2, what are the natural sources of methyl salicylate? We have the following: the twigs of Gaultheria procumbens, and then the bark of Betula lenta. Number 3, what method is used in the extraction of methyl salicylate in plants? The main method would be maceration, wherein you would place the plant parts, particularly the leaves of the plant, in a solvent and allowing it to stand, and then followed by steam distillation of the menstruum to concentrate the 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 desired product or the desired active principle in your plant. Okay, next, number 4. Uh, what is the use of methyl salicylate? Give the examples of its preparations available in the market. Now, methyl salicylate is mostly available in our liniments rather. Yes, liniments. Its main use is for the temporary relief of mild to moderate aches and pains of muscles and joints associated with arthritis, simple backache, strains, sprains, cramps, and bruises. Examples of liniments that we have in the market, we have Salonpas, Efficacent, Omega, Magzone, etc. Okay. And then for number 5, why is the internal use of methyl salicylate limited to short quantities only? Because methyl salicylate is too toxic to be taken internally in large quantities. So examples of the toxic effects, we have neurotoxicity, bronchospasm, hyperuricemia, and many more. Okay. The next part, we have the post-lab for experiment number 6, the synthesis of ethanol or ethyl alcohol. Now, actually, this experiment was kind of a fail for us because we did not exactly uh, separate a pure product. So to explain why, we have the initial experimental setup here. Ang ginawa natin, di ba, we had two Erlenmeyer flasks, and these two Erlenmeyer flasks are connected by a bent tube. On one Erlenmeyer, or in one rather, Erlenmeyer flask, we placed glucose and yeast or nutrient mixture. And then on the other Erlenmeyer flask, we filled it with lime water. Okay, and then the mixture is allowed to stand for 2 weeks at room temperature. Okay, now the principle here is via fermentation. Now, alcohol is produced as a fermentation product of glucose. So we have the chemical reaction, glucose with yeast forms your ethanol with the liberation of carbon dioxide. Okay. Now, after allowing it to stand for 1 to 2 weeks, this would be your parang expected na output or result dapat. So as you can see here in this illustration, parang may mga deposits tayo of precipitation sa vent tube as well as on the, or rather in the flask containing your calcium hydroxide or your lime water. Now, nangyari dito is that the carbon dioxide that was produced as a byproduct of the mixture, it reacted with your calcium hydroxide, forming calcium carbonate, which is technically a white precipitate, or yeah, or the presence of a precipitate. So you may wonder, sir, bakit may mga precipitate tayo sa vent tube? So have you heard of the process called capillary action, wherein yung fluid pwede siya mag-adhere sa walls sa isang tube. So that's why parang merong mga precipitation sa vent tube as well. Now, this lime water reaction, it is used to indicate if fermentation took place, as evidenced by the presence of the white precipitate, the calcium carbonate. So after 2 weeks or 1 to 2 weeks, if may makita kang precipitation, it goes to show, or it's a positive result that fermentation really took place. Okay. Now, the next step would be to separate the alcohol that was produced in the fermentation step via distillation. So in the nutrient glucose mixture, alcohol and water are both present. Pero ang kailangan mo lang talaga, it's the alcohol. And these two liquids have two different boiling points. So to separate the two, the method that you could use would be distillation. So we have the distillation set up here. We have the distilling flask and then the condenser, which is very important in distillation because it is where the gases are converted back to their liquid state. Now, the principle in distillation is that um, water and air should be at opposite ends. So, ibig sabihin, sa dulo ng condenser, yung malayo sa heating mantle, dito yung water in natin. And then, yung malapit sa distilling flask, yung water outlet dyan, that would be your water out. Okay? So, meeting at opposite ends. Now, the product supposedly of distillation would be the separation of your alcohol. And medyo critical tayo pagdating sa temperature dito because the temperature for alcohol, it's around, rather the boiling point rather for alcohol, it's around 78 degrees Celsius, whereas for water, it's around 100 degrees Celsius. So probably during distillation, pwedeng masama yung water pag distill along with your ethanol. Okay, next we have the identification test, physical and chemical tests. For physical test, for the synthesized ethanol mixture, color is colorless, followed by odor, characteristic odor siya, particularly because fermentation or products of fermentation have a distinct smell. Physical appearance is liquid, and the theoretical boiling point, it's 78.37 degrees Celsius. Now, for the chemical test, we have three of them. We have combustion, oxidation, and the reaction with acetic acid and sulfuric acid. We only performed two for some sections. We did not proceed with three. For the combustion test, as you all know, alcohol is highly combustible. So in the presence of flame, it should ignite or combust. Okay. However, in our experiment, we did not, or there wasn't really ignition, or parang wala talagang flame, primarily because during distillation, pwedeng nasama yung water along with your alcohol, or probably ang na-distill would be um, mostly water. So that's why na-put off ang flame. The next one would be oxidation test. Oxidation test, we made use of potassium permanganate. Now, potassium permanganate, it's orange solution. When reacted with ethanol, and subjecting it to heat for a long time, eventually there would be a precipitate formed in the product or in the mixture rather. That precipitate form would be your chromium sulfate. That's the green coloration here. And yung color ng solution natin, it would become darkish. Darkish siya in color. And the last chemical test, reaction with acetic acid and sulfuric acid. Now, this one is the positive result here would be to check on the odor. So ethanol, when reacted with acetic acid and sulfuric acid, it would form an ester. So it is still an esterification reaction. So dapat it should form or it should have a plastic balloon or minty odor as a positive result. Okay? Again, it's an esterification reaction. Okay, to answer our follow-up questions, number one, what concentration range of ethyl alcohol is considered bactericidal? So alcohol's bactericidal activity drops sharply when diluted below 50% concentration. And the optimum bactericidal concentration of your alcohol in water, it's around 60 to 90%. What are the important sources of ethanol today? The most important source would be the fermentation of molasses from sugar. And additionally, ethyl alcohol can also be prepared synthetically by the action of sulfuric acid, catalyzed titration of ethylene. And number three, we have what is the mechanism of action of ethyl alcohol? Ethyl alcohol as a bactericidal agent, it acts via protein denaturation, wherein it changes the normal structure or the normal configuration of the protein found on its surface, particularly affecting bacteria or any tissue that comes in contact with ethanol. Number four, how does the structure of aliphatic alcohol affect its bactericidal effectiveness? The antibacterial potencies of primary alcohols increase with increasing molecular weight until 8 carbon, and then the branching of the alcohol decreases antibacterial potency. But this is not the case, particularly pag i-compare mo ang isopropyl versus ethyl. So a lowered concentration of ethyl is better to a higher concentration na ethyl alcohol. Related din siya sa lecture na to. And then the last one, what alternative alcohol shows equal antiseptic properties as ethyl alcohol? Isopropyl alcohol shows equal antiseptic properties as ethyl alcohol. Ganun nga lang na mas mababa ang percentage for isopropyl. And then propylene glycol is also claimed to be effective as ethyl alcohol in its power of inhibiting mold growth and fermentation. And that's it for the post-lab discussion for experiments 5 and 6. Refer to your handouts. Okay? So thank you, everyone.